All right, so now kind of we can fill out this spot right here. So if we know that there are 35 people who slept 7 hours and 23 of them are here, 35 minus 23 is going to give me 12 here. So then I can do 48 plus 12 would give me a total of 60 people here. And I would put here that the total is 100. So we had 100 people here. And you can kind of figure that out, whether we're doing 40 plus 60 is 100 out of the coffee, or from the sleeping, 6 hours or 7 hours, 65 plus 35 gives you 100 as well. All right. So then our first question on the table is testing independence from a table. And so are drinking 0 cups of coffee and sleeping 7 hours independent events, okay? So we did this yesterday on a Venn diagram. So we said over here how we test for independence. I circled it right here in blue. Is if the probability of A and B equals the probability of A times the probability of B. So we calculate each one of these two separately. If they're the same, then they are independent. If they are different, then they are not independent, okay? So we got to calculate this probability of A and B, and then the probability of A times probability of B, okay? So let's call drinking 0 cups of coffee, let's call that A. And then sleeping 7 hours, let's call that B, okay? So then the probability of A and B would be, out of everybody, how many people did we have that drank 0 cups of coffee and slept for 7 hours? I see that as 23, okay? This box right here, they drank 0 cups of coffee and they slept 7 hours. These 23 people are the and then it's out of everybody. I actually don't even need a calculator to calculate that one because I know it's just going to be 0.23 or 23%. Okay, so now we need to calculate what's the probability of A times the probability of B. So now I'm separating them. So out of everybody here, what's the probability that a random person drank 0 cups of coffee? So out of everybody, how many people drank 0 cups of coffee? The answer is going to be 40. Because now I'm talking about all the people that drank 0 cups of coffee. So that's all 40 of these people over here, these 17 and these 23 people, okay? I'm going to multiply that by the probability that somebody slept 7 hours. So out of everybody, how many people slept a total of 7 hours? That would be 35. All right. So I can do that on a calculator. And that comes out to 0.14. 14%. So since those two answers came out differently, these are not independent events. It's only independent if those two probabilities come out exactly the same, okay? All right, so that's testing for independence again, but now on a table. Now we're going to get some review on this idea of the given. So given that he didn't drink any coffee, okay? So if Jared randomly picks a day from his data, what is the probability that he slept exactly 6 hours given that he didn't drink any coffee? So didn't drink any coffee is this whole row right here. So when they use that word given, I assume that like these are the only people in the world for this problem for part B. So I'm doing my probability. that changes my denominator to just 40. So I'm not looking at everybody anymore. I'm just looking at the people who did not drink any coffee. So out of those 40 people, how many drank exactly, or sorry, how many slept exactly 6 hours? That would be 17. So I would put that at 42.5%. All right, one more here. What is the probability that on a randomly selected day from the data, Jared A either drank no coffee or slept 7 hours? So since there's no given here, they don't say the word given. This is out of the whole data, so it's out of all 100 days. And so we either need to drink no coffee or slept 7 hours. So it could be this one, it could be this one, or it could be this one. You can see on those three, on the 17 here, he drank no coffee, so that counts. On the 12 here, he drank 7 hours, so that counts. And then the 23 here, he did both, so that counts as well. So 17 plus 23 plus 12 is 52. That'd be 52%. All right, a quick note back to A. Remember what I said, that if these are not independent, that means they're dependent. That means the amount of coffee that he's drinking is probably affecting the amount he sleeps, right? He's getting more sleep when he does not drink coffee. And so some people may say, like, hey, look, 23 versus 12, that's not a big difference for the 7 hours, whether he drinks 0 cups or 1 cup. But if you look at the 6 hours, he's getting a lot more of those 6 hours of sleep when he's drinking the coffee as opposed to no coffee, okay? So it seems like if he doesn't drink coffee, he's getting more sleep, which I think is scientifically proven, right? And so when we say that's not independent, that's what that's saying, is that the coffee is affecting his sleep. If it was independent, then it wouldn't matter whether you drank coffee or not, you would get the same amount of sleep, all right? All right, let's do a couple more here. Okay, so this goes back to actually that we did this Venn diagram earlier, but we're going to answer some different questions on it. So we talked about, they gave them this medication to half the people, and some of them lowered their blood pressure, and some of them who didn't get the medication lowered their blood pressure. So it says, what is the probability that randomly selected individual lowered their blood pressure given that they are on the medication? So we see that phrase given again. We didn't see this before on the Venn diagram, we only saw it on the table. But we can still do it here. So given that they're on the medication, our denominator should be all the people who are given the medication. So that is these groups, right? So 365 plus 135 would be 500. So then out of those 500, how many lowered their blood pressure? That would be the 135 in the middle, correct? Because those are the 135 out of those 500 who lowered their blood pressure. So this comes out to 27%. So then what if we change the order on that given? Does it change it? The answer is yes. We saw before the numerator should actually be the same, but the denominator should change. So given that their blood pressure lowered, means we're looking at these people now in our denominator. So our denominator is 135 plus 245, that's 380. But the numerator is still these 135 because we're saying out of the 380, how many were on the medication? So that's 135 still. So this comes out to about 35.5%.